Hello everyone! In this video, I'm going to show you how to install and run Flux AI in ComfyUI. The release of the new text-to-image model, Flux, is already sparking incredible ideas from the community. The results are promising, with text generation using simple prompts producing high-quality outputs. First, visit the ComfyUI page by Comfy Anonymous. By following the instructions there, we will download a few models before using Flux in ComfyUI. Back on the page, a few requirements need to be installed. The first to install is the clip models. Then download the clip L model, which is mandatory. Click the arrow next to the model and save it into your ComfyUI directory, specifically into the models clip folder. Next, if you have more than 32 GB of system RAM, download the FP16 Safe Tensor model. However, if you have less than 32 GB of RAM, download the FP8 model instead. I'll proceed with the FP8 version. Click the download arrow and save it into the same folder as the clip model. Now, you'll also need a VAE model for Flux. Download the file named AEESFT and save it in ComfyUI under Models VAE. Once this is done, return to the page. There are two variants of the Flux models, the Flux Dev model and the Flux Chanel model for commercial and personal use. Download the Flux Chanel model, which we will be using. Save it under Models Unit. Once all the requirements are downloaded, open ComfyUI. It may take some time to start due to the initial installation of all the models. Once ComfyUI is open, it's important to update everything. Go to the manager and click Update All to update all custom nodes. Then, update ComfyUI itself, which is very important. After updating, restart ComfyUI to avoid any outdated nodes, which can affect the workflow for Flux. Next, head back to the web page and save the workflow image. Since we are using the Flux Chanel model, right-click and save the image. Drag and drop the saved image into ComfyUI to load the workflow. Looking at the workflow, you'll notice it uses a sampler custom node instead of the K sampler. Now, let's go through the nodes of the Flux workflow to input settings and test it out. Zoom into the first node, which is the Low Diffusion node. Load the Flux channel model we just downloaded and select the appropriate weight type. If you have more than 32 GB of RAM, leave the weight type at default. Otherwise, select FP8 to avoid out-of-memory errors. Next is the dual clip loader. Set clip name 1 inch to the FP8 model we downloaded. Ensure it matches the weight type selected in the Low Diffusion node. If using FP16, use the default weight type. If using FP8, select FP8 in both nodes. Clip name 2 inches will be the clip L model we downloaded earlier. Now, zoom out to the clip text encode node. This is where you'll input your usual positive prompts. Notably, the workflow does not include a negative prompt node. Below this is the empty latent image node, which controls the image size. Choose any resolution compatible with SDXL. I'll use a 1:1 ratio and I'll leave the batch size at 1 for now. Next is the random noise node, which handles the seed numbers, either fixed or randomized. Scroll down to the sampler selection and leave it on YOLA for now. You can experiment with other sampling methods later. Leave the basic scheduler node at its default settings, as Flux Chanel only takes 1 to 4 steps for image generation. Moving on to the VAE node, the model should already be selected by default. Finally, scroll to the right to find the Save node. With all inputs aligned, use the queue to generate the default prompt and check if everything works correctly. The rendering time might take longer the first time, so be patient. Once the initial generation is done, subsequent generations will be much faster. If everything runs smoothly with the default prompt and workflow, you're ready to experiment with different prompts and explore your ideas. If this video helped you out, feel free to buy me a coffee using the link in the description. This will support the channel so I can keep making more videos like this.